For the first part of lesson 9.1, we are now getting into the chapter on integration. Integration is the process of finding the antiderivative. So what we've done in the past with our calculus has been to find a derivative using the power rule. So if we had x squared, we were taking our exponent, multiplying it to the front, subtracting one from our exponent, and we would get this term right here, and this was the derivative. However, now through integration, we can go from here to here and get the antiderivative. So we're now just going the other direction on these. One thing to keep in mind is when you take a derivative, remember what happens to the constant. When you find the derivative, your constant goes away. And so if we're now going to go the other direction, how are we to know what that constant was? Since we don't know, we always replace it with the variable, and that's our c value that we put right here. That is called our constant of integration. This is a really important part of doing your integration, is simply because this could represent any number. If you were to start with this function and find the derivative, you would get 2x, but you would also get 2x with this function. And so this constant could be any number, it could be nothing, but we don't know. So we always represent that with a plus c to represent any constant. We refer to this as a family of functions because we can now place any constant here, and that would fit what we started with. So really important step. A lot of people lose points constantly throughout the year for forgetting to put a plus c on this. It costs you points, so just be careful. So a little bit on vocabulary and notation. So the little S looking shape that you see right here is for taking an integral. Whatever you are integrating is called the integrand. The differential, little dx right there. The antiderivative is what you end up with after you integrate. We can also call that the integral. The process of finding an antiderivative or the process of anti-differentiating is the same thing as the process of integrating. So those two words are synonymous with each other. So you're going to run into both throughout the chapter. So looking at the power rule, so keep in mind when you were to find a derivative in order, you would take the exponent, you would multiply it to the front, and then subtract one from the exponent. Well, if you were to do that in reverse, you would add one to the exponent and then divide. And so that's going to be the process that we do on this. There's kind of a lot going on here. Let me give you a quicker explanation of what you're seeing on this. Simply put, you can see this is x to the first right here. And so if we do our process of adding one to the exponent, this would become x to the second. And then if we divide by whatever this exponent is, we're going to have 2x to the second over 2. And then yes, those 2's will cancel out, and we're going to come up with x to the second. And then you will always throw in your plus c for your constant of integration anytime you're doing an indefinite integral. So here's the rule that you want to know for this. So again, this is what we did. We added one to the exponent, and then whatever this number became our denominator. So you can either think of it as dividing by this number or multiplying by 1 over this number, same thing. But in any case, whenever you're doing this process, so you're going to see the integral symbol here. This is what tells you to integrate or to anti-differentiate, same thing. And then you always have the dx right here, the differential. And so this is what we are shooting for when we end up with this. Keep in mind that if you have a constant, like we did on this last problem, so your constant was 2, right? We don't deal with that until the end of the problem. In a lot of cases, it will either reduce or cancel with whatever our denominator is. And so you'll see a few examples of that right here. As we go through a few of these, again, feel free to pause at any time and give one or two a try on your own. But again, if we go through the rule that you see right here, we're simply adding one to the exponent. This becomes a 7, and then we put 7 as our denominator. And you could either write that as x to the 7th over 7, or you can pull the 1/7 out front, x to the 7th. Either way, it doesn't matter. Just don't forget the plus c. Right here we have a constant, so this is what this rule is referring to. So k is 18. So when we start going through the process, we just kind of pull the 18 out to the front, save it for the end of the problem. So we're just looking at the x squared for now. We're going to add one to the exponent, so it becomes x to the third. Since this became a 3, that becomes our denominator. So we're going to divide by 3 or multiply by a third, same thing. And then now we can link it up with the constant here and reduce as much as possible. So this is where we would end up with. Again on this, and again, these are all kind of more of the same, so feel free to give some of these a try. But again, you're going to add 1 to your exponent, it becomes a 6. 6 becomes your denominator. And then if you reduce your 1/6 times 2, this is where you would end up. And again, a lot of times you'll see this as x to the 6th over 3 instead of pulling out the 1/3, but it means the same thing. Here's just another one. You know, we've dealt a lot with before when we were doing derivatives about putting things into friendly terms. And so this would be one of those cases where we're going to want to see 1 over x to the third as x to the negative 3. Now we can go through with our process. If I add 1 to negative 3, I would get negative 2. So negative 2 becomes my denominator. And at the end of all this, so that we don't have to leave a negative exponent in our answer, we can also bring the x squared on bottom and write it like this. Don't forget the negative. You could either put that here or here, it doesn't matter. Again, another process of just putting things into a friendly format with radicals. So if this is 6 times the square root of x, we're going to see that as x to the 1/2 power. Go through your process. If I add 1 to a half, I get 3/2. So if my exponent is 3/2, that means I'm going to divide by 3/2, or you can think of that as multiplying by the reciprocal, which is multiplying by 2/3. And then now we can simplify the 2/3 times 6 and get this look right here. To finish things off right here, also we dealt with when we did the power rule. When you have a lot of terms separated by pluses and minuses, you just go on down the line and do each term individually. So if this is what we had to start with, so if we were going to find the integral of this function right here, again, you're going to add 1 to your exponent, so this will become x to the third divided by 3. So those 3's would cancel, and you get this as your first term. Second term, this would become x to the second over 2. And so that gives us our second term that you see here. And then lastly, think of this as 2x to the 0. So we're going to add 1 to that and get 2x to the first over 1, which gives you this as your last term. And then as always, don't forget the plus c at the end of all that. And we got our family of functions.